Hi, it's me Tutor Binod. In this series, we are going to have a complete review of Mechanics of General Physics 1. I want to assure you that at the end of this series, your mechanics understanding will be greatly enhanced. Now let's get started with vectors. We have two kinds of physical quantities. One is scalar and one is vector. Scalar has only magnitude. Vectors quantity has both magnitude and direction. So whenever we are dealing with vectors, we should remember that we should include both magnitude and direction. We have to understand how to geometrically add or subtract vectors. In order to add two vectors geometrically, we can have the vector as it is copied. So let us say vector A is this one. So if you want to find a plus b, we can add the b vector as it is, as on the same direction and of the same magnitude. So this has the same direction and magnitude as this one. So let us say this is vector b, which is of the same magnitude and in the same direction as it is here. Now if you want to connect the tail of the first vector with the head of the second vector, in this case the first vector is vector A, whereas the second vector is vector B. If you connect it, you're gonna have the third vector, which is known as, let us say, C vector, which is A vector plus B vector. In this way you can geometrically add two vectors. Similarly, you can have B vector first. Let us say this is B vector, and you can add A vector to the tail of it. So if I gonna add A vector over here, this is A vector. Now connect the tail of V with the head of A vector, you will get this B plus A vector. So A plus B vector and B plus A vector are of same magnitude and direction is also same. So its vector addition is commutative because A plus B is equal to B plus A. Similarly, the vector additions are associative. If you have three vectors, if you want to have A plus B plus C, which is also equal to A plus the sum of B plus C. So vector addition are commutative and associative. If you want to add a vector with the negative of the same vector, then you would get 0, because if you have a vector as this, if you want to add negative a to this one in this direction, obviously you will have 0 because of the same magnitude and opposite in direction. Now let us talk about the components of vectors. Let us say we have the vector A, which is at theta degree with the positive x-axis. This is our x-axis and this is our y-axis, which the vector A makes theta degree with positive x-axis. The projection of this vector onto x-axis, which is this one over here, is known as our x component of the given vector A. Similarly, the projection of this vector A onto the y-axis or onto the positive y-axis is known as the component or y component of this vector A. So ax and ay are our component of vector on x-axis and y-axis. Let us find the value of ax and ay. Suppose I have the magnitude A. The magnitude of vector A is simply A. So I have, if I want to use the property of right angle triangle, I have hypotenuse, I need base in terms of A, and I have the given angle theta. I can easily find cos theta as base or adjacent over hypotenuse. My base is ax over my hypotenuse is A. Therefore my ax is a cosine of theta. Similarly, if I use the same over here, this will be my theta, and from here my sine theta will be p over h, or perpendicular over h. Perpendicular is ay over my hypotenuse is vector a, or in fact the magnitude of vector a, which is a. Therefore my ay will be a sine theta. So the x component of vector a, which is ax, is a cosine of theta. Similarly, my y component is a sine of theta. You can also find the tan theta, which is perpendicular over base. Perpendicular is also equal to ay, so my tan theta will be ay over ax, or simply you can divide equation 2 over equation 1 to get tan theta, which is equal to ay over ax, and your theta will be tan inverse of ay over ax. So in this way you can find the components of a vector. Similarly, we can also find the magnitude of vector a by ax square plus ay square. These are the properties of component of vectors you should know. Now let us talk about unit vectors. As the name suggests, if the magnitude of a vector is 1, we call those vectors as unit vectors. If we want to talk about the three-dimensional vector analysis, we have I, j and k as unit vector along x-axis, y-axis and z-axis respectively. I refer to as unit vector along x-axis, and j cap referred to as unit vector along y-axis, and our k cap will represent a vector along z-axis, which is of unit magnitude. The application of unit vectors are very handy in addition, subtraction and different operation of vectors of higher dimension. Also, if I have vector, now let us talk about vector product and scalar product of vectors. Vector product is denoted by a cross b, which is given as the z vector, which is av sine theta, also known as cross product of the vectors. The direction of the cross product is given by the right hand rule. The right hand rule suggests us that if we want to have the cross product of two vectors, suppose I have a vector in this direction and b vectors with this magnitude in this direction, if I want to have a cross product of these two vectors, I can place two vectors attaching a tail of one vector with the another vector with their respective direction. Now if I use my right hand to indicate one vector and modify my fingers towards the direction of the second vector, the outward pointing arrow of the thumb of my right hand will give me the direction of the a cross b. So in this case, if I have my fingers pointing the vector a, and if I turn to my left towards the vector b, my thumb will be pointing upward, so the direction of the vectors will be upward as shown in the second figure over here. So this is how we use right hand rule in order to find the direction of vector product, whereas the magnitude of vector product will be av sine theta. Now let us talk about the scalar product of a given vector a and v. Suppose I have vector a and v. The scalar product of a vector, scalar product of a vector a and b is denoted by a dot b, or also known as the dot product of two vectors, is av cosine theta. Since the result is a scalar, that's why it is also known as scalar product of two vectors. Suppose if I have a as ax I plus ayj plus azk in terms of izk vectors. Similarly, I have b vector as bxi plus byza plus bzk. I can have scalar product of this vector as a dot b, which is ab cosine theta, which is also equal to ax vx plus ay by plus az vg. In this way we can find the scalar product of the given vector if they are given in terms of ij and k. Now let us see a few examples regarding vectors. I have a vector as 2i plus 7j plus 8k, whereas b vector as 3i plus 7j plus 9k. I'm supposed to find a dot b, which is scalar product of a and b, vector product a cross b, and a plus b and a minus b. Let me start with the easier one. So let us do 4 first. A minus b, which is difference of two vector a and b. Let me write a as it is, 2i plus 7j plus 8k minus 3i plus 7j. I need to subtract this vector. You can use either the horizontal arrow as this or the cap this. Usually people will put cap because it's a unit vector. If you also put the horizontal arrow on top of the vector, it's completely fine. So let us see what we get. So if I gonna subtract 3i from 2i, I would get negative I. If I gonna subtract 7j from 7j, I would get plus 0j. Plus if I gonna subtract 9 from 8, I would get negative k. So this is our a minus b, or vector a minus b. Similarly, we can get number 3 quite easily, which is the sum of two vectors. You just have to add each component of two vectors. So if I add the x component of two vector, which is 2 plus 3, which is 5i, plus if I add the j component or the y component of two vectors, I would get 7 plus 7, which is 14j, plus if I want to add the k component or g component of two vectors, which will be 8 plus 9 is 17k. In this way we can find a vector plus b vector. Now let us find a dot b. A dot b can be found as multiplying the component, I mean to say the x component of vector a and vector b by adding with the y multiplying the y component of vector a and b, add that off with the multiple of g component of 8 and 9, I mean to say a and b, to get the scalar component. So this is 6 plus 7 times 7 is 49 plus 8 times 9 is 72. So you add them together to get the answer of a dot b. It's a scalar quantity. But now if I want to find a cross b, it's a little bit difficult. I'll take the determinant of this, which is the easiest technique in order to find the vector product. Now write the a vector. A vector is 2i 7j. Let me write only the component part, 7j plus 8k. Similarly, my v will be 3, 7 and 9. Now take the determinant of this matrix. So let me put I. So I will close this row and column which consists of this I. So I would have 7 times 9, 7 times 9 minus 7 times 8 minus j. Now it's 2 times 9 minus 3 times 8, 2 times 9 minus 3 times 8 plus k. Now I will have 2 times 7 minus 3 times 7. So on calculating this, you will find the vector product of 2 vector a cross b. In this way we will do the problem regarding vectors. I hope this video helps you to understand the vector and the operation of vectors, including vector addition, vector subtraction, and multiplication of vector. I mean to say the scalar product and vector product of 2 vectors. And also, if you have not yet subscribed my channel, please subscribe it and hit the bell icon so that you won't miss any future update. Thank you. Stay safe and healthy in this pandemic.